So hello everyone, in this audio class we will read the chapter number 14, Movements of Ocean Water, from the book Fundamentals of Physical Geography, Class 11 Geography textbook NCERT. So let's get started with the chapter number 14, Movements of Ocean Water. So the ocean water is dynamic. Its physical characteristics like temperature, salinity, density and the external forces like the sun, moon and the winds influence the movement of ocean water. The horizontal and vertical motions are common in ocean water bodies. The horizontal motion refers to the ocean currents and waves. The vertical motions referred to tides. Ocean currents are the continuous flow of huge amount of water in a definite direction, while the waves are the horizontal motion of the water. Water moves ahead from one place to another through ocean currents, while the water in the waves doesn't move, but the wave trains move ahead. The vertical motion refers to the rise and fall of water in the oceans and the seas. Due to the attraction of the sun and the moon, the ocean water is raised up and falls down twice a day. The upwelling of cold water from the subsurface and the sinking of surface water are also forms of vertical motion of ocean water. Next is waves. So waves are actually the energy, not the water as such, which moves across the ocean surface. Water particles only travel in a small circle as a wave passes. Wind provides energy to the waves. Wind causes waves to travel in the ocean and energy is released on shorelines. The motion of the surface water seldom affects the stagnant deep bottom water of the oceans. As a wave approaches the beach, it slows down. It is due to the friction occurring between the dynamic water and the sea floor. And when the depth of water is less than half of wavelength of the wave breaks. The largest waves are found in open oceans. Waves continue to grow larger as they move and absorb energy from the wind. Most of the waves are caused by the wind driving against water. When a breeze of 2 knots or less blows over calm water, small ripples form and grow as the wind speed increases until white caps appear in the breaking waves. Waves may travel thousands of kilometers before rolling ashore, breaking and dissolving as surf. A wave's size and shape reveal its origin. Steep waves are fairly young ones and are probably formed by local wind. Slow and steady waves originate from far away places, possibly from another hemisphere. The maximum wave height is determined by the strength of the wind, how long it blows and the area over which it blows in a single direction. Waves travel because wind pushes the water body in its course while gravity pulls the crest of the waves downward. The falling water pushes the former troughs upward and the wave moves to a new position. The actual motion of the water beneath the waves is circular. It indicates that things are carried up and forward as the wave approaches and down and back as it passes. Next is characteristics of waves. So wave crest and trough. The highest and lowest points of a wave are called the crest and the trough respectively. Next is wave height. It is the vertical distance from bottom of a trough to the top of a crest of a wave. Next is wave amplitude. It is 1/2 of the wave height. Next is wave period. It is merely the time interval between two successive wave crests or troughs as they pass a fixed point. Next is wavelength. It is the horizontal distance between two successive crests. Next is wave speed. It is the rate at which the wave moves through the water and it's measured in knots. Next is wave frequency. It is the number of waves passing a given point during a 1 second time interval. Next point is tides. The periodical rise and fall of sea level once or twice a day, mainly due to the attraction of the sun and the moon, is called a tide. Movements of water caused by meteorological effects, that is winds and atmospheric pressure changes, are called surges. Surges are not regular like tides. The study of tides is very complex spatially and temporally, as it has great variations in frequency, magnitude and height. The moon's gravitational pull to a great extent and to a lesser extent in the sun's gravitational pull are the major causes for the occurrence of tides. Another factor is centrifugal force, which is the force that acts to counterbalance the gravity. Together, the gravitational pull and the centrifugal force are responsible for creating the two major tidal bulges on the earth. On the side of the earth facing the moon, a tidal bulge occurs, while on the opposite side, through the gravitational attraction of the moon, is less, and as it is further away, the centrifugal forces causes tidal bulge on the other side. The tide generating force is the difference between these two forces, that is gravitational attraction of the moon and the centrifugal force. On the surface of the earth nearest the moon, pull or the attractive force of the moon is greater than the centrifugal force, and so there is a net force causing a bulge towards the moon. On the opposite side of the earth, the attractive force is less and it is further away from the moon, and the centrifugal force is dominant. Hence, there is net force away from the moon. It creates the second bulge away from the moon. On the surface of the earth, the horizontal tide generating forces are more important than the vertical forces in generating the tidal bulges. The tidal bulges on the wide continental shelves have greater height. When tidal bulges hit and the mid-oceanic islands, they become low. The shape of the bays and the estuaries along a coastline can also magnify the intensity of tides. Funnel-shaped bays greatly change tidal magnitudes. When the tide is channeled between islands or into bays and estuaries, they are called tidal currents. Next is tides of Bay of Fundy, Canada. The highest tides in the world occur in the Bay of Fundy in Nova Scotia, Canada. The tidal bulge is 15 to 16 meter. Because there are two high tides and two low tides every day, roughly a 24-hour period, then a tide must come in within about a 6-hour period. As a rough estimate, the tide rises about 240 centimeter an hour. So 1440 centimeter divided by 6 hours. If you have walked down a beach with a steep cliff alongside, which is common there, make sure you watch the tides. If you walk for about an hour and then notice that the tide is coming in, the water will be over your head before you get back to where you started. Next point is types of tides. So tides vary in their frequency, direction and movement from place to place and also from time to time. Tides may be grouped into various types based on their frequency of occurrence in one day or 24 hours or based on their height. Next point is tides based on frequency. First is semi-diurnal tide, the most common tidal pattern featuring two high tides and two low tides each day. The successive high or low tides are approximately of the same height. Next point is diurnal tide. There is only one high tide and one low tide during each day. The successive high and low tides are approximately of the same height. Next is mixed tide. The tides having variations in height are known as mixed tides. These tides generally occur along the west coast of North America and on many islands of the Pacific Ocean. Next point is tides based on sun, moon and the earth position. So the height of rising water or high tides varies appreciably depending upon the position of the sun and moon and with the respect of the earth. Spring tides and neap tides come under this category. First is spring tides. The position of both and sun and moon in relation to the earth has direct bearing on the tide height. When the sun, the moon and the earth are in a straight line, the height of the tide will be higher. These are called spring tides and they occur twice a month, or one on full moon period and another is new moon period. Next is neap tides. Normally there is a 7-day interval between the spring tides and neap tides. At this time, the sun and the moon are at right angles to each other and the forces of the sun and the moon tend to counteract one another. The moon's attraction, though more than twice as strong as the sun's, is diminished by the counteracting force of the sun's gravitational pull. Next, one in a month, when the moon's orbit is closest to the earth, that is called perigee, unusually high and low tides occur. During this time, the tidal ranges is greater than normal. 2 weeks later, when the moon is farthest from the earth, which is called apogee, the moon's gravitational force is limited and the tidal ranges are less than their average heights. When the earth is closest to the sun, that is called perihelion, around 3rd January each year, tidal ranges are also much greater with unusually high and unusually low tides. When the earth is furthest from the sun, that is called aphelion, around 4th July each year, tidal ranges are much less than average. The time between the high tides and low tide, when the water level is falling, is called ebb. The time between the low tide and high tide, when the tide is rising, is called the flow or flood. Next point is importance of tides. Since tides are caused by the earth, moon, sun positions which are known accurately, the tides can be predicted well in advance. This helps the navigators and fishermen plan their activities. Tidal flows are of great importance in navigation. Tidal heights are very important, especially in harbors near rivers and within estuaries having shallow berths at the entrance, which prevent ships and boats from entering into the harbor. Tides are also helpful in desilting the sediments and in removing polluted water from the river estuaries. Tides are used to generate electrical power in Canada, France, Russia and China, and a 3 megawatt tidal power project in Durga Duani in Sundarbans of West Bengal is underway. Next point is ocean currents. Ocean currents are like river flow in oceans. They represent a regular volume of water in a definite path and direction. Ocean currents are influenced by two types of forces, namely primary forces that initiate the movement of water and the secondary forces that influence the currents to flow. The primary forces that influence the currents are the heating by solar energy, wind, gravity, Coriolis force. Heating by solar energy causes the water to expand. That is why near the equator the ocean water is about 8 cm higher in level than in middle latitudes. This causes a very slight gradient and water tends to flow down the slope. Wind blowing on the surface of the ocean pushes the water to move. Friction between the wind and the ocean surface affects the movement of water body in its course. Gravity tends to pull the water down the pile and create gradient variation. The Coriolis force intervenes and causes the water to move to right in the northern hemisphere and to the left in the southern hemisphere. These large accumulations of water and the flow around them are called gyres. These produce large circular currents in all the ocean basins. Next is characteristics of ocean currents. Currents are referred by their drift. Usually the currents are strongest near the surface and may attain speeds over 5 knots. At depths, currents are generally slow with speeds less than 0.5 knots. We refer to the speed of a current as its drift. Drift is measured in terms of knots. The strength of current refers to the speed of the current. A fast current is considered strong. A current is usually strongest at the surface and decreases in strength or speed with depth. Most currents have speeds less than or equal to 5 knots. Differences in water density affect vertical mobility of ocean currents. Water with high salinity is denser than the water with low salinity, and in the same way, cold water is denser than the warm water. Dense water tends to sink while relatively lighter water tends to rise. Cold water ocean currents occur when the cold water at the poles sinks and slowly moves towards the equator. Warm water currents travel from the equator along the surface, flowing towards the poles to replace the sinking cold water. Next point is types of ocean currents. The ocean currents may be classified based on their depth as surface currents and deep water currents. Surface currents constitute about 10% of all water in the ocean. These waters are the upper 400 meter of the ocean. Deep ocean currents makes up the 90% of the ocean water. These waters move around the ocean basins due to variations in the density and gravity. Deep waters sink into the deep ocean basins at high latitudes, where the temperature are cold enough to cause the density to increase. Ocean currents can be classified based on temperature as cold currents and warm currents. Cold currents being cold water into warm water areas. These currents are usually found on the west coast of continents in low and mid latitudes, true in both hemispheres, and on the east coast in the higher latitudes in the northern hemisphere. Warm currents bring warm water into cold water areas and are usually observed on the east coast of the continents in the low and mid latitude, true in both hemispheres, and in northern hemisphere they are found on the west coast of the continents in high latitudes. Next point is major ocean currents. Major ocean currents are greatly influenced by the stress exerted by the prevailing winds and the Coriolis force. The oceanic circulation pattern roughly corresponds to the Earth's atmospheric circulation pattern. The air circulation over the oceans in the mid-latitude is mainly anticyclonic, more pronounced in the southern hemisphere than in the northern hemisphere. The oceanic circulation pattern also corresponds with the same. At the higher latitudes, where the wind flow mostly cyclonic, the oceanic circulation follows this pattern. In the regions of pronounced monsoonal flow, the monsoon winds influence the current's movement. Due to the Coriolis force, the warm currents from low latitudes tend to move the right in the northern hemisphere and to the left in the southern hemisphere. The oceanic circulation transports heat from one latitude belt to another in a manner similar to the heat transported by the general circulation of the atmosphere. The cold waters of Arctic and Antarctic circles move towards the warmer water in tropical and equatorial regions, while the warm waters of lower latitudes move polewards. The major currents in the different oceans are given in the figure 14.3. Next and last point, effects of the ocean currents. So ocean currents have a number of direct and indirect influences on human activities. West coast of the continents in tropical and subtropical latitudes, except close to the equator, are bordered by cool waters. Their average temperatures are relatively low with a narrow diurnal and annual ranges. There is fog, but generally the areas are arid. West coast of the continents in the middle and higher latitudes are bordered by warm waters which cause a distinct marine climate. They are characterized by cool summers and relatively mild winters with a narrow annual range of temperatures. Warm currents flow parallel to the east coast of the continents in tropical and subtropical latitudes. This results in warm and rainy climates. These areas lie in the western margins of the subtropical anticyclones. The mixing of warm and Cold currents help to replenish the oxygen and favor the growth of planktons, the primary food for fish population. The best fishing grounds of the world exist mainly in these mixing zones. Thanks for listening. Keep listening for the further audio classes. Thank you.